Hi guys, it's Ms. Griffin. We're taking a look at Unit 6, Skill 4. Your essential question for today is, what is the relationship between sine and cosine and how is it used? So we're talking about these things called cofunctions. And sine and cosine are cofunctions of one another due to this special relationship that you see here. Sine of theta is equal to cosine of 90 minus theta. Now remember, theta is just an angle, so maybe you would need to write that over here off to the side. This could have been an x instead of the theta. We're just talking about two angles whose sum is equal to 90, because if you take theta plus 90 minus theta, well, the thetas cancel, so then you're just left with 90. So I want you to write here that these two angles add to 90. And when we have two angles whose sum is 90, that's called complementary. Just like supplementary are two angles whose sum is 180, complementary two angles whose sum is 90. Now if you think you might get confused between the two, here's a little trick for you. Supplementary starts with SUPP. We can turn this into a 180 by putting a 1 in front, change the S to an 8, and turn that into a 0, right? That's a little bit of a stretch, but complementary is even better in that it starts with COMP, blah, blah, blah. Turn the C into a 9 and you already have your 0. Complementary is 90, supplementary is 180. The relationship we're talking about here today is 90. So in example 1, this was a Common Core question. It says, find the value of r that will make the equation sine of 73 equals cosine of r true when r is between 0 and 90. Explain your answer. So again, the relationship when sine and cosine are set equal to each other, as you see here in this bubble, when they're set equal to each other, their angles add to 90. So we know that r and 73 should sum to 90, because again, sine and cosine are set equal to each other. So those two values have to add to 90. So you just do a little bit of math, you subtract 73 and you get r equals 17. And this is degrees because we're talking about angles. So now we need a because statement since it says explain your answer. So the reason that they're looking for on the Common Core exam is that sine and cosine of complementary angles are equal. Sine and cosine of complementary angles are equal. Now, if you forget the word complementary, you can just say because sine and cosine of angles whose sum is 90 are also equal. That works too. So then you have 3 questions here that say practice, find the value of r that will make the equations true. Now, if you go back to this example up here, example 1, and you type in sine of 73 on your calculator, you're going to get a pretty nasty decimal, and that's okay. But you can always check your answer by plugging in what you found. So you type in sine of 73, you get an answer. Then you type in cosine of 17, you get that same exact answer. Obviously, because it says equals. If you don't get the same answer, then clearly you did something wrong. So I'm going to start you with this first one, practice A. Then you can check your answer, move on to the next one, check your answer, move on to the next one. Hit play when you're ready to move on to example 2 so that you can see my work, but also check your answers with my answers. So again, we know that we have sine set equal to cosine, so r and 56 should be added to 90. Now each of these examples do have r's in them, but it could be a different letter besides r. Could use any letter other than r. I just stuck with the r when I was making this packet because the first example had r. Okay, so we subtract 56 and we're left with r equals 34. And again, this is because sine and cosine of angles whose sum is 90 are equal. All right, go ahead, pause the video, try parts B and C of this practice section, and then hit play when you're ready to see the answers and move on to example 2. Okay, so for part B of practice, you should have r equals 64, and C, you should have r equals 7. Again, just taking those values and summing them to 90. Example 2 was a Common Core question at one point or another. It says, which expression is equivalent, meaning equal to, sine of x, when x is between 0 and 90. So because it has to be between 0 and 90, we again know that it's complementary, because again, 90 is the value of complementary angles. And so here we know that we have x plus something should be equal to 90. We don't know exactly what that something is, but we can look at our choices here, and we know that in order to have something equal to 90, we can't just have the value of x itself, right? Because we don't know what x is, and it may not always be true, right? What if x is 10? That I can't have 10 plus 10 equals 90. That doesn't work, okay? Now here we saw the example up top where we knew that if we took x and we took it away, but we had another 90 in there, it would equal to 90 because the x's cancel. Now that means that our answer is choice B, but let's talk about why it can't be choice A. If we had 45 minus x and then plus the x from the sign equal to 90, x's cancel, but then we have 45 is not equal to 90. So A doesn't work. The next one we have 2x plus the x from the sign should be equal to 90. This actually forces x to be equal to 30 if you were to solve it. But is x always going to be 30? Nope. And then again, you could go through the same process with choice D. X plus x equals 90. That forces x to be 45. We don't know that x is always 45. So here, if you choose choice B, it allows x to be whatever value you want it to be because they cancel out in the first place. All right, flip it over. And we have example 3. This one was, again, a Common Core question. It tells you that the value of angle C is 90 degrees. Now, if we just think for a second, angles in a triangle equal 180, correct? Yeah. Okay, so that means that if I have A plus B plus 90, meaning C, should be equal to 180, I take away the 90 and I am left with A plus B equals 90, right? 3 angles in a triangle, A, B, and the value of C are equal to 180. Take away that 90 and we're left with 90 again. So A plus B is equal to 90. These two values, these two angles, are complementary. Guess what we know then? Their sine and their cosine are equal. Okay, so again, if you have two angles whose sum is 90, the sine and cosine must be equal. So if you go through your choices, again, this was a Common Core question, and this, to me, seems like a no-brainer. We have sine with sine. We never put sines together. We have cosine with cosine. Again, never put cosine and cosine together. It's always sine equals cosine of something. Okay, so now we see that we have cosine with sine, cosine with sine. But notice here in choice C that we have sine of the 90-degree angle. You have never been circling the 90-degree angle in any of the previous skills, right? Like you have never circled the right angle in any of these problems, so you're still not going to talk about it here. Because if you think about this for a second, cosine of A is equal to sine of 90 degrees, because we know that C is 90. And these two are supposed to add to 90. Well, if one of them's already 90, that means that A has to be 0 degrees. And that just clearly does not work. You can't have an angle of 0 degrees within a triangle. So we're down to choice D and only choice D, because cosine of A is equal to sine of B, because A and B summed to 90. Okay, one more Common Core question for you, and then you're on your own for practice. It says we have this triangle ABC where C is a right angle, so you may want to consider sketching it. C is a right angle, A and B are somewhere on here. We have the cosine of A is equal to square root 21 over 5. Now you know that from SOHCAHTOA, cosine is adjacent over hypotenuse. So I'm going to circle angle A on my picture just so I can label the sides because it might help me figure this out. Cosine of A is equal to square root 21, over 5. Notice how I place them because this is my adjacent side, this is my hypotenuse, this is my opposite, based on angle A. So then it says, what is the sine of B? Now, if I do a different color for B, here's B. Sine of B, well, sine is opposite over hypotenuse. So here I have opposite, here I have hypotenuse. So that means sine of B should be equal to square root 21 over 5. Right? Opposite over hypotenuse, based on the picture that I already had labeled. So wait a second. We're saying again that cosine of A is equal to square root 21 over 5, and sine of B is equal to square root 21 over 5? Yeah, we're saying that. Because again, remember, if C is the right angle, then A plus B sum to 90. If they're complementary, then these two expressions must equal each other. Cosine of A must equal sine of B, meaning whatever the value of cosine of A is must be the same as the value of cosine of B. So here we actually get to just choose choice 1. And this problem is actually a really nice problem to explain why this cofunction relationship works, because you're using the same set of sides for two different angles. Right, when we talked about A, we have adjacent and hypotenuse, but when we talk about B, that original adjacent and hypotenuse is now the opposite in hypotenuse. So cosine of one is equal to sine of the other. There you have it. Good luck on your practice. Let us know if you have questions.